Hello, and this video is on section lesson 5-1. We are talking about operations with functions. Learning targets are to combine functions using arithmetic operations and build functions that model real-world scenarios. This begins on page 73. Now remember that from our function cycle, functions, we begin with the equations. And from the equations we can find what the table is, what the ordered pairs are, and from the ordered pairs we can find the graphs. And so there are many representations for a function. In this case, we're going to be focusing on just the function in the form of an equation. And what does it mean when we perform operations, arithmetic operations on functions? Well, we're going to be adding, subtracting, multiplying, and dividing functions. And so what does that mean? If a function is basically can be represented as a table, ordered pair, graph, how is adding, subtracting, multiplying, and dividing functions going to look like using this function notation? Well, in the beginning here, we had a person called Jim. Jim has a lawn service called Jim's Grass Guaranteed. Jim and not Jim, but let's say here Tim and Sam are two of his employees. Tim earns $10 per hour and Sam earns $8 an hour. Jim sends Tim and Sam on a job that takes them 4 hours. Question number 1. Write a function t of h to represent the earning in dollars for working h hours and a function s of h to represent earnings in dollars for working h hours. So right away with the first question we begin to build functions that model real-world situations. And so basically t of h represents Tim's earnings per hour and s of h represents Sam's earnings per hour. And these are very simple functions to build. How much does Tim earn an hour? $10 per hour. So 10 times the number of hours is going to give me the earnings for Tim. How much does Sam earn per hour? $8 an hour times the number of hours basically gives me the earnings. So if they're both working on a 4-hour job, we can find out how much their earnings are after those 4 hours. Basically find t of 4, multiply 10 times 4, that gives me $40. And for Sam, it's going to be s of 4, so 8 times 4, which is $32. So Tim makes $40. Sam makes $32. Find t of 4 plus s of 4 and tell what it represents in this situation. So my students were able to find that right away, and this became $72. What does the $72 represent? Again, we want to know what they model in real-world situations. It represents the total amount that Tim and Sam made. You can add two functions by adding their function rules. So again, we're still talking about function rules. These are the function rules. And so if we wanted to add t of h plus s of h, this is what the notation looks like. T plus s of h. Well, this is a new type of notation here. I mean, I don't think we've seen this before. How am I going to use this to find what t of h plus s of h are? Well, what is t of h again? It's basically 10h. So 10h goes here, and then s was 8h. And that's basically it. So one important thing here is don't get confused by this h right here. This h is basically telling me what the variable is. And so, as you can see, our variables are h's here. And so remember, going all the way back to the function notation, which is f of x, this is the original way we're used to seeing a function being called. This is basically like a title. It tells me that it's a function, and then this x right here tells me that is the variable we're going to be using. So what do I mean by a title? Well, it's like Mr., Mrs., Sir, Madam. Same thing in mathematics. This notation right here is basically a title for the function. A function is called f of x. Now, when you add two functions together, here's the title right here. But the title is, in mathematics, gives us a lot of information. We're basically adding the function t plus the function s together, which is where these two things came from. And then h basically tells me what the variable is. Alright, so if I add these together, I just basically combine like terms. 10h plus 8h is basically 18h. And so what does 18h represent? Well, it's going to, I'm going to leave it for you guys to decide what is 18h going to represent. And so now it wants us to do t plus s of 4. Well, that's basically 18 times 4, which is basically plugging in 4 in for h. And when you multiply this out, you're going to see that it equals 72. So how much will Jim spend on Tim and Sam's earnings for the 4-hour job? It's going to be $72. So can you see how first, just going by the individual functions, calculating them individually to find how much the total cost is for Tim and Sam's earnings, we get the same answer if we add the functions together and make just a single calculation. So as you can see, the first thing that we just did is we added functions together. And it turns out it's actually pretty simple. All you have to do is combine like terms, basically. Alright, let's take a look at an example here for a basic tree trimming job. Jim charges customers a fixed $25 fee plus $150 per tree. One of Jim's competitors, Vista Lawn and Garden, charges customers a fixed fee of $75 plus $175 per tree for the same service. Write a function j of t to represent the total charge in dollars for trimming tea trees by Jim's company, and a function v of t to represent the total charge in dollars for trimming tea trees by Vista. Okay, so again, we want to build functions that model real-world scenarios. So again, we have a real-world scenario here. What is going to be the function j of t? And what is going to be the function v of t? So pause the video right here and read this information carefully. Okay, so basically, what does j of t and v of t represent? It represents the total charge in dollars for trimming tea trees. So we know that T stands for trees. And so a fixed $25 fee for Jim plus $150 per tree. That's basically it. Here is the function. V of t, on the other hand, we have $75 fee plus 175 t per tree. And that's it. That's basically the two functions. Number 9, subtract j of t from v of t to find v minus j of t, then simplify the function rule. Okay, so now what we're going to be doing is subtracting functions. So let's take a look here. So we're taking v of t, and we're going to write that down first, and we're going to subtract j of t. And if you write them in this format, it's actually very simple. And so when you multiply v of t minus j of t, the notation looks like this. Again, this is the title of it. The first parentheses tells me that I'm subtracting v minus j, and the second parentheses tells me what the variable is. And so now I can start simply subtracting 75 minus 25. Well, that's 50. 175t minus 150t. Well, that's basically 25t. Yeah, 25t. That's it. Here's my answer. That was pretty simple. Now, there's a different way we could have done this as well. We could have written 75 plus, we could have written it like this. V minus j of t is equal to 75 plus 175 t parentheses minus 25 plus 150t. Now it's very important that we put each of the functions in parentheses, because since we're subtracting, that means that we're going to have to distribute this negative into each of the parentheses. So when I distribute that negative, I can get rid of the parentheses, and what I have is negative 25t, negative 25, I mean, minus 150t. And so now that I have this, I don't need the parentheses anymore. I can just basically combine like terms. 75 minus 25 is 50, and then 175t minus 150t is going to be 25t, and I get my answer. So there's two ways you could have done this. You could have just set the functions on top of each other and subtract in this manner, or if you worked it out like this, you have to put parentheses around the functions. That way you remember to distribute. Okay. What does the function v minus j of t represent in this situation? Alright. B, 9b, and 10, I'll leave it up to you to find out what the answer is. Alright. Here are some examples that I wanted you guys to work out to get familiar. We did this during class. Again, remember, when you're adding functions, you don't have to put parentheses. Here's the first one. F of x, f plus g of x basically means to add 3x plus 2 and then plus 2x minus 1. You could put parentheses, but it's not really that necessary. But once you do start subtracting functions, as for example f minus g of x, you do need to put parentheses. Why? Because this negative right here means that you have to distribute it to the 2x and to the negative 1. And so what you get is 3x plus 2 minus 2x plus 1. And then you can find the correct answer from there. Okay. Jim has been asked to make a bid for installing the shrubs around a new office building. In the bid, he needs to include the number of shrubs he can install in an 8-hour day, the cost per shrub including installation, and total cost of his services for an 8-hour day. Okay, so in 13a, write a function n of h to represent the number of shrubs Jim can install in an 8-hour day when it takes him 8 hours to install one shrub. Again, going all the way back to the learning targets, we want to know how to build functions that model real-world scenarios. Here's a really challenging one. So pause this video, read all this information, and come up with the function. Okay, so first of all, what does n of h represent? It represents the number of shrubs. How do we get the number of shrubs? Well, we have an 8-hour day, and h represents the hours to install one shrub. So if I have an 8-hour day, and it takes me 8 hours to install one shrub, how many shrubs can I install in 8 hours? So you just basically take the number of hours, the total time I have, divided by the number of shrubs it takes me to install one, the number of hours it takes me to install one, and that gives me the number of shrubs. That's it. Now, B is very, very important. What are the restrictions on the domain of n of h? Explain. So we just found that n of h is equal to 8 over h. Now, restrictions on the domain. Basically, that's asking what value I can plug in. H is my variable. This is my variable. So I can plug in any number here for h. H stands for the number of hours. Basically, you're looking for what numbers can I put in for h. Since h represents the number of hours, let's see here. Number of hours. What numbers are we talking about when we're talking about hours? Well, we can talk about 0 hours, 1 hour, 2 hours, 3 hours. Can we talk about negative hours? Nope, that doesn't make sense. So we need to put the restriction that h has to be greater or equal to 0 because we're talking about hours. Now here's another thing. Can I plug starting from 0 all the way to 5, 6, keep on going? Can I plug if I plug any of these numbers, is it always going to work out? Well, take a look at this. What if I plugged in 0 here for h? So n of 0 is equal to 8 over 0. Is there a problem here? Yes. Remember, and I'm pretty sure almost all your math teachers have told you this, you can never divide by 0. And so that's the domain restriction right there. H cannot equal 0, so that means that we cannot use h is greater than or equal to 0. H has to be it has to be greater than 0. So any value of h greater than 0 is going to work. And so that's the domain restriction right there. H cannot equal 0. Well, h has to be greater than 0. Alright. Jim will charge 16 for each shrub. He will also charge $65 per hour for installation services. Write a function c of h to represent the amount Jim will charge for a shrub that takes h hours to install. Okay, so again, $16 for each shrub. He will also charge $65 per hour for installation services. And this is going to be the function right there. The total cost of Jim's services for an 8-hour day is equal to the number of shrubs he can install times the charge for each shrub. Find the total cost of Jim's services using the functions n of h and c of h to find n times c of h, then simplify the function rule. Okay. So now we're taking the function n and c, and this time we're going to be multiplying functions. How is that going to look like? So remember, every time when you're multiplying functions, you want to put each function in parentheses. So our first function was n of h, which was 8 over h, times c of h, which we just found to be 16 plus 65h. 16 plus 65h. And you know what? I want to verify if that is what I should have. 16 plus 65. Yes, 16 plus 65h. Okay. So again, remember, this is the notation for multiplying functions. N and C basically tell me what I'm multiplying together. And the H, again, I've seen some students make this mistake. They think the H is something you should also multiply. Nope, that's not it. This basically, this first parentheses tells you what functions you're using and what the operation is. And the second parentheses tells you what the variable is. So in this case, my variable is h, which is what I have here, h and h. Alright, now we're ready to multiply. What we want to do is we basically want to distribute the 8 over h. So what this is going to be is 8 times 16 over h plus, since I have this plus here, 8 times 65h over h. And there we go. I distribute the 8 over h, and now I can go ahead and simplify, which I'll write down here. 8 times 16 128 h plus 8 times 65, and that's going to be 520. Now notice that we have h over h. Those go away. They basically simplify to 1, and so this is what I have. N times c of h is equal to 128 over h plus 520. So we just basically multiplied those two functions. Again, the restrictions, since we have h in the denominator, we want it to be greater than 0, and because we don't want it equal to 0 or else we get something that's impossible, and since h does stands for hours, we want the hours to be positive. Okay. So you can do the rest here. I just want to skip over to dividing functions. And basically we already got a taste of what we need to do for dividing functions. Multiplying functions, what you want to do is you always want to put each of the functions in parentheses. So f is 2 of x times x plus 3. So again, you're going to have to distribute for when you're multiplying functions. Here you have x plus 3 and 2x plus 6. Again, you want to distribute here. And notice each of the parentheses has two terms, so you're going to have to distribute this x times the 2x, the x times the 6, and then you also have to distribute the 3 times the 2x and the 3 times the 6. So let me just give you a quick preview. 2x times 2x is 2x squared. X times 6 is 6x. 3 times 2x is again 6x. And then 3 times 6 is 18. And then you just simplify after that. Now, when you're dividing functions, basically the same thing. You put each function in parentheses. Here we have 2x divided by h of x, which is 2x plus 6. Now, don't make this mistake. You might want to cross out the 2 x's. That's not going to be the case, because this 2x plus 6, they are together. You can't cross them out because they are in parentheses together. But here's the important thing. For adding, subtracting, and multiplying functions, you just basically give me the answer. But there's also something that we did extra for multiplying functions, and something that we always have to do for dividing functions, is notice that when we had the variable in the denominator, we have to find what the restrictions of the domain are going to be. In this case, we found that h has to be greater than 0. Same thing that we have to do here. We have a variable in the denominator. That means I have to figure out what value of x can I not have so that my answer in my denominator is not equal to 0. So a really quick way to find that out is just take the denominator, 2x plus 6, set it equal to 0, and solve for x. So minus 6, we get 2x equals negative 6 divided by 2, and so x equals negative 3. And here is going to be my domain restriction. X cannot equal negative 3. Why? Well, let's see what happens when I do it. I basically plug in negative 3 for x, and when I simplify this, let me do that again. When I simplify this, I get negative 6. 2 times negative 3 is negative 6 plus 6 is 0. Can you see what the problem is with this? We're dividing by 0. That's not possible. And so this is why I want to set the domain restriction. X cannot equal 0. Because if I let it equal to 0, I'm letting myself divide by 0. Or if I let x equal to negative 3, it leads me to divide by 0, which is what I don't want. Same thing with this one, h divided by g of x. H is 2x plus 6 divided by g of x, which is x plus 3. Again, you have to figure out what value of x can x not equal to, because you want to prevent dividing by 0. Alright, and then we also had some more practice on lesson 5-1. Alright, so that has been the operations on functions. We added, subtracted, multiplied, and divided functions. For dividing functions, and possibly for multiplying functions, you have to tell me what the domain restrictions are. Alright, thank you for watching.